Okay, so it's 1 minute until the start time, so I will start because I'm very poor at timekeeping. I'll just stop the slideshow because fun things happen. Okay, so what we're going to be talking about today, when I say we, I mean me, are the Earth Sciences degrees that are on offer at Edinburgh. So I'll give a brief introduction to just what Earth Sciences are, because some of you might not be so kind of familiar with the subject, which is not taught at most schools. And then I'll talk a little bit specifically about what it's Edinburgh Earth Sciences teaching is and what we do. Mention some of the kind of things we do for teaching, field trips and labs and practicals and that kind of stuff. And hopefully convince you that you not only definitely want to do an Earth Sciences degree, whether that's geophysics or geology or environmental sciences, but that you want to do it at Edinburgh, which is, here, and it's a good place to do it. But I'll convince you, hopefully, during the talk. First of all, I guess just to highlight the importance of the subject. So this is a picture of another lecture theatre in the university. All lecture theatres look very similar. There's an old guy at the front, usually with a beard, a bunch of very interested students, some of them taking notes, doing some learning, all fantastic stuff. But the reason I show this picture is because if you look around this room, and also this room, and in fact any room, everything in that room has either been made out of something that's been dug out of the ground, okay, so, or extracted from the ground, like all this plastic flooring, this plastic carpet here, that's come out of some kind of petroleum product. The metal from the seats, also coming from the ground. Even the wood from the desks, and some of the desks here are at least partially made of wood. I mean, those are plants that have grown using elements that have ultimately come out of the ground. So whether it's something that's been extracted by industrial activity, or there's some kind of understanding of the transfer of elements between the Earth and the biosphere that's gone on to produce all of this stuff. So without kind of the Earth Sciences, none of the stuff that we have in this room, even the power from the lights, even if like most of the power from our lights in Scotland is coming from wind farms, understanding where to put those wind farms, how to make sure that the ground is stable that they're going on, finding all of the resources to build those turbines and the distribution network, those are Earth Sciences kind of problems. And actually, particularly with wind farms, that energy is quite intermittent. Okay, so sometimes the wind blows, sometimes it doesn't. So figuring out how to store all of that energy, these are Earth Sciences problems as well. So one of the areas of research that is currently going on in the School of Geosciences in Edinburgh is understanding how we can use old oil and gas reservoirs to store things like compressed air or hydrogen that can act as energy stores which we can draw on when the wind doesn't blow. So it's basically the utility of the subject is maintaining our advanced society. Without Earth Sciences, none of this would happen. So I guess that's one of the reasons why we do it, but we also do Earth Sciences because we are just genuinely interested in how the Earth works. So this can be done through just very simple observations. So quite a lot of the science that particularly geologists do are done by just looking with our eyes and making things like geological maps to figure out how parts of the Earth worked. Now, we've kind of moved on a little bit from just looking with our eyes through using all of the physical sciences, so using physics, chemistry, biology, to use tools from those subjects to look at and understand how the Earth works. So that could be something like this image over on the bottom left. This is a satellite image of the ocean colour. So this is telling us about the biological processes that are going on in the ocean, but also we need an understanding of the physics of how that ocean is moving around, bringing in elements which are essential for this life to happen. So we can look remotely, also to understand the atmosphere, but we can also use other parts of the physical science. We can use gravity or seismic waves to understand the internal processes going on in the Earth. We're all about looking and understanding the Earth as a system, as a whole. It can't be really escaped, the climate change problem as well. So this is also an Earth Sciences problem in kind of all kind of ways of using the word, it's our problem. So we did it, right? We dug all the stuff out of the ground and burnt it and put it in the atmosphere. But how we found out about kind of global warming and how we understand how it's progressing, this is also basically an earth sciences thing. So understanding how the climate has been changing, but also understanding the pattern of change. This is, well, that's embarrassing. Someone from the university is ringing me. Right. Sorry about that. Sure, it was important. Yeah, so understanding this pattern and understanding why it's happened, that's also an earth sciences kind of area of investigation. But also, what are we going to do about it? So the idea that we're going to keep kind of global temperatures to 1.5 degrees Celsius above pre-industrial levels, it's a noble goal. It can't be done without taking carbon dioxide out of the atmosphere and putting it in the ground. And you can't do that without an understanding of how those geological reservoirs work. Okay, so it's very much our problem. So I guess what I'm trying to get at is that there are a number of different justifications for wanting to do the subject. We can be interested in how the Earth works just as an intellectual activity, and that's why most people that are researchers are employed. That's why they want to do it, because they really want to understand how the Earth works. But I mean, that quite often doesn't, pay the bills, as it were, as a university goes. So we're also interested in using this knowledge of how the Earth works to basically find and use resources that will basically allow society to continue. But now, more importantly, is actually this cleaning it up bin as well. This not bin, field in this kind of Euler diagram that I've tried to draw here. Is that when we use these resources, we need to do it in a responsible way. We need to make sure that when we put our waste back in the ground, it doesn't mess everything else up. So this is an active. These both are active areas of both kind of like employment for our students, but also areas in which we are actively researching. And then the third kind of like area that we're kind of interested in are the natural hazards that the Earth kind of gives us, or doesn't so much gives us, but so much like punishes us with. So this is an important kind of justification for understanding how the Earth works, because that helps us understand, what the risks are from volcanoes, earthquakes, landslides, tsunamis, these kind of geological hazards. Okay, so I'm going to talk a little bit now about Edinburgh and the earth sciences that we do here. So Edinburgh is a really good place to come and study earth sciences, partially because it's where the subject was historically developed. The first geologists were in Edinburgh, and that's kind of nice to be in the same place that this kind of historical development happened. But it's not kind of actually that directly relevant to the stuff that you'll be learning, because the science has kind of moved on somewhat. But it is kind of nice that the city of Edinburgh has all of these classic sites that we can go to kind of teach the important concepts, such as kind of the vastness of geological time, or the kind of the intrusion of igneous rocks beneath sedimentary rocks, and how important these are for kind of the development of the site. So we're able to go to these sites because they are here. And also, Edinburgh is in Scotland, and Scotland is a fantastically geologically diverse country. You can see all of the different kind of this geological map here. I won't go into the details of that, but Scotland is basically made up of lots of different types of geology. And we make use of that extensively throughout our teaching program, so hopefully these will appear rather slowly through time. I should speed up this animation. These are just some of the places that we go on our undergraduate teaching within Scotland to make use of the geological diversity. So we go to, am I going to have to press the button again? There we go. So we go to Mull, where there's an enormous supervolcano. We go to kind of the coast around East Lothian. So this is an example of where the crust was being pulled apart. So it's very much like going to the East African Rift in the Midland Valley, except it's more convenient. The north of Scotland, it's very much like the, going to the Alps, but going to the Alps then eroding away all of the mountains so you can see inside what's happening. Okay, so we make use of the fantastic geology of Scotland. This is Edinburgh. We also make use of Edinburgh, so we have our own volcano. So there's the Carboniferous volcano of Arthur's Seat here. There's actually another volcano just near us here. This is an Ordovician volcano. So there's a lot of geology within the city that we kind of use. I should also use this slide to point out kind of where we are. We're at King's Buildings. And the teaching of the, particularly the pre-honours courses in Earth Sciences will be jointly between sites down in the George Square area and King's Buildings. It's not far. It's an 11-minute cycle for me. Most of the first-year accommodation is over here in Pollock Hall. So although it might appear that it's not in a campus-type space, the city is actually quite compact and easy to get around, as well as having interesting geology. And a beach. Not many people know we have a beach. It's not that nice, but we have one. Yeah, so the old dead white guys. It's nice to have these old dead white guys because they provide some context to some of the simpler context that we do. This, for instance, anybody that's doing maybe geology A-level, geology higher, it's not happening away. If you have a textbook, it will probably have this figure in it, this photograph. So this is known as, it's a site at Sicker Point. It's known as Hutton's Unconformity. It's one of the places where we first figured, well, James Hutton, figured out that the age of the Earth is very, very long. I mean, he got it wrong. He said it was an infinite age, which it is not. But yeah, so we go to these places and we can tell these stories kind of in situ, which is quite nice. The other thing, the reason I show this slide is actually this guy here, this John Playfair. So all of these other guys are, well, they're all guys, so there's one thing. They're all scientists. But John Playfair was just a really rich guy that wrote really good books. These guys, good scientists, terrible books. And the point I'm making here is that you have to be able to communicate your science. So this guy was really pivotal in the Scottish Enlightenment in communicating all these new scientific ideas. And this is part of what we teach throughout our degree program. It's not just learning the stuff, it's getting those transferable skills of being able to communicate your ideas, whether that through reports, essays, posters, vlogs. You need to be able to communicate those ideas. And we try and embed that throughout all of the courses that we do, in that we change the kind of the mode of communication as part of the assessment throughout. So, for example, the course I've just finished in Oban, part of the assessment is to basically, instead of writing an essay about the history of Loch Etive, which is fantastic, you make a kind of a leaflet for tourists in the area to tell you about something sciencey in the loch, okay? Which Doug will be doing, right? He's already thought of some ideas. Anyway, yeah. So we also have some people that are not dead. So one of the really good things about Edinburgh for students is that the School of Geosciences, where the Earth Sciences degrees is, we are really big. As kind of Earth Sciences or Geosciences or whatever we want to call it these days. Our department is one of the biggest in the world. Okay, certainly one of the biggest in the UK. And what this means for you guys is that there is a huge range of expertise across a load of different subjects. So when it comes to doing option courses in the fourth year, sometimes in the third year, and in the pre-honours, there's a lot of choice. And when it comes to doing your research dissertations, there's also a lot of choice. You're not limited to like what the one guy that's available wants to do. Yeah, so we have some really fantastic people. I should point out that although some of these people are big fancy pants professors, so Gabby is probably our biggest fancy pants professor, you cannot get a job as a lecturer in Edinburgh unless you're committed to teaching or a professor. It doesn't matter how many Nobel Prizes you've got, okay? You have to do the teaching. And that means that we only get people who are committed to doing teaching as hires. So. Right, so we're going to talk a bit about the degree programs that we offer. We offer many degree programs, geology, physical geography, environmental geoscience, and a variety of different geophysics flavours. So rather than look at this slide, or in fact this slide. It's basically just point out that although there are lots of different degrees, there's a lot of overlap between them. Okay, and I want to just show this. So this is some pictures of things to do with volcanoes. We might have a volcano erupting, and geologists would be interested in that. They might want to come along and say, well, actually, where does the magma that is erupting, where does that actually come from? Where is that generated in the Earth's crust? What determines how much is generated? They might go to the volcano and they might say, well, what deposits can we find? How has that volcano changed through time? Has it always erupted the same, or does it go through cycles of different kinds of eruption? Geologists might also take samples of rock and make thin sections of it. Some of you coming on the tour will see some of these thin sections. To understand what processes have gone on underground in the magma chamber leading up to eruption. Was it a sudden increase of temperature or a sudden increase of water that have caused this eruption? So that's kind of what a geologist might do on a volcano. Maybe a geophysicist and meteorologist might be more interested in what happens when the products of that volcano, all this ash, when that gets up into the atmosphere. What happens to it? How does that affect clouds? Does that make them whiter, last longer? Does it make them rain out more? Does it change the chemistry of the clouds? Does it change the depletion of ozone? How does the impact of on the atmosphere affect climate? Does it make it warmer, cooler? Depends on what gases are being given out. Looking at this image here, you can't quite make it out. So this is volcano in Iceland, which I'm not going to try and pronounce. And you can see this big cloud of ash here. But you might just be able to make out this kind of like slightly bluer, greeny splodge over here. This is what maybe an environmental geoscientist might be interested in. They might be looking at what happens when the things that come out of the volcano, when they go into the ocean, what does that do to the phytoplankton in the ocean? What does that do to the productivity of the region? Does it make it, does all the ash suddenly kill everything? Does it add lots of pollutants? Or is it adding elements which are critical for life, which allow life to thrive? We might also look at the CO2 that's being given off locally around maybe some volcanic vents that are in the ocean, and seeing how that's changing the chemistry of the water. How does that affect the organisms that are living there? Is it making all the corals dissolve and die? Or is it actually allowing more photosynthesis because there's more CO2 in the water? We might have geophysicists that come on and they look at the volcano in a very similar way to the geologist. They might want to understand how it works, but they might use a different set of tools. They might use seismic or earthquake measurements, looking at how does the volcano behave just as it approaches eruption. So you can see here we've got basically time relative to the explosion. So the eruption happens kind of here at 0. And leading up to the eruption, you can see we've got these earthquakes which have got, starting off with a very low frequency, their frequency seems to change characteristically just before eruption. So that's telling us something about the physics of what's happening in this magma chamber as it's kind of just preparing to erupt. The physical geographies, or the geology and physical geographers, might come along and they might look at the same volcano and not be so much interested in the generation of the magma in the ground, but they might be looking at what are the products of that eruption, what happens when those land on the Earth's surface. So how does that affect maybe agriculture? How does it affect the risk of landslides? And what happens to that sediment when it gets into rivers? So it's not maybe just the direct impact of landsliding from the volcano, but you might also get sediment remobilization, which changes the flood risk in the region. Okay? So that's kind of, I mean, it's one example of volcanology. There are lots of other aspects of the Earth which all of these degrees can look at, but they basically look at the Earth in their different ways. So yeah, so we have the geology degree, which is more into looking into the deep Earth, kind of below the crust, and understanding how we can get things out of that, put them back in, understanding the processes which drive change in the Earth's crust. Also interested in how the Earth has changed through time, so particularly with relevance to the life on Earth through paleontology and dinosaurs. I should have mentioned we had Steve, the dinosaur guy. If you like dinosaurs, we have a guy called Steve who writes lots of books about dinosaurs. They're really good. Buy them. Yeah, so these are kind of the words that are related with geology. Environmental geoscience is very similar to geology to start off with. It's all about kind of looking at the Earth, but it's really focused a little bit more on the interface between the solid Earth and the things that live on the Earth. Okay? So it's how, coral reefs, where do they get their nutrients from? How do they interact with the ocean and its chemistry? It also has more of a focus on the kind of the climate aspects of the Earth system. So how has the Earth's climate, particularly looking into the past, using geological evidence for past climate change to understand how the Earth worked. So one of the areas that I research on is sea level, understanding how ice sheets have responded to global climate changes in terms of melting or growing, and how we can work out things like rates of change from past coral reefs. Here's another Wordle. Probably change that. Right, so as I mentioned, the geology and physical geography, this is a degree program that really focuses on the physical processes that occur at the Earth's surface. So looking at erosion, weathering, landscape dynamics, how do kind of landscapes evolve and change over time, and how does that affect the hazard that we associate with those landscapes, about landslides, those kind of things. There's quite a strong element of remote sensing and how we can use kind of geospatial data, so building up databases kind of geographically as part of this degree. This is probably our most flexible degree in terms of the number of options that you can take from other courses, particularly in the third and fourth year. There's like a little Wordle of stuff that's to do with geography. And the geophysics. We have a range of geophysics courses. And we have straight geophysics, geophysics that focuses on the atmosphere, geophysics and meteorology, and geophysics that focuses on kind of the more resource-based geology kind of stuff. So geophysics we have lots of those. The degree structure, this will be the same across most of Scotland. So in the first 2 years, we have the pre-honours, which doesn't count towards your overall degree classification. You have to pass it. But this will usually involve a range of core courses just for your degree, and then a range of options. And those options can be really broad in almost any subject. I should mention there is an option for almost all of our degree programs to do direct entry into the second year. And all that means is that we take all of the core courses that you would have done across 2 years and condense them into 1 year. So you don't get any options to do kind of wacky stuff like French or politics or more geography. You just focus on the degree that you are doing. Okay, it takes 1 year less long, but you get less flexibility and choice. In the third year, most of our degrees have very few options, and we focus on getting you the skills and really core knowledge that will allow you to do your research dissertations in the fourth year. And in the fourth year, you'll do those dissertations, but focus also on a few core courses to your degree that bring kind of the whole degree together, but then also some options in there as well. And we also have, for all degrees except the environmental geoscience degree, this option of doing this integrated undergraduate masters, which really allows you to follow a more research-based path. You do a much more extended individual research dissertation and research kind of based courses. If you're interested in doing something like that, have a chat with me afterwards or whatnot, and we can discuss the merits of that versus regular masters or not. So just quickly, this is the degree structure, or these are the degree structures for the geology, environmental geoscience, and geology and physical geography degree. So in the first year, you'll do a bunch of courses that are core to the program. So Earth dynamics is about basically introductory geology, how the Earth works, introduction to geological record, start building up skills about how we make observations in the field of rocks and how we can make interpretations about geological history from those. Evolution of the living Earth is, of course, all about how life evolved on Earth, how it became a habitable planet, and how it's changed through time in terms of the life that lives on it, but also the climate history of the Earth. So it has a little bit about how the climate system works. Also brings in some basic chemistry in there as well. And then depending on your maths, we'll ask you to do some maths or not. And then you'll have some option courses, which can be in anything. Now, the important thing is that at the end of the first year, you don't really need to have decided which degree you go on to do. You can switcheroo between these guys. It's in the second year that you kind of start to specialise into your chosen degree areas. So if you do environmental geoscience, you'll do more kind of marine science with oceanography and environmental geochemistry of the Earth's surface, looking at chemistry of rivers and lakes and soils and that kind of thing. If you do physical geography, you'll do a geomaterials course. Not geomaterials, geomorphology. Geomaterials is this one. It's all about basically mineralogy. What is the stuff that the Earth is made of? You'll do, if you do geology, you'll do a bit of geophysics, and you'll do a course called Global Tectonics of the Rock Cycle, which kind of brings together kind of the concepts of plate tectonics and how we can then relate those deformation events and those crustal formation events to the sedimentary basins and kind of the rocks that are then formed in them. Geophysics is the same, but different, in that you have a core first year, but this time there are no options in the first year. You do physics courses that the physicists do, and then you do some of the geology courses. And then you start to specialise, just like with the other degrees, into the second year. Okay? And the core things here is that you do a little bit more maths in the second year and a little bit more geophysics with physics of the Earth. But you then start to specialise into your degree programme. So if you're doing the meteorology stream, you do some courses in meteorology. How does the atmosphere work? How does it circulate? And how does it kind of, how does it determine what the Earth's climate is? Yeah, and we've covered the courses there. So into the junior honour years, or the third year if you're doing the 4-year degree programme, we're really building your skill set. I'm not going to go through all of these kind of courses here, but for instance, if you look at the geology programme, we've got a course in geochemistry and data analysis. So this will have a little bit of theory about how we use chemistry to understand kind of Earth processes, but it also includes aspects of how to do computer programming, how to do data analysis, how to do report writing. We have, in environmental geoscience, we have one in hydrogeology and geophysics. So this introduces some of the theory of how fluids move through rocks, which is important if you want to pump water out of the ground to drink. And we all like drinking water, right? It's very good for us. And some of the basic techniques of how we can practically use these geophysical techniques to investigate the ground. So we go out and do seismic surveys and electromagnetic surveys and those kind of things. And then moving on into the fourth year, we start to introduce a little bit more options again in the fourth year in terms of you'll do some core courses which kind of like really define what the degree is, and then you'll do some options. But this time, the option courses that you take are limited to options within the School of Geosciences rather than out anywhere. And you will do an independent research project, and that counts for a third of your final year mark. It's quite a substantial project. If you're doing a geology degree, there's a geological mapping exercise. We'll see an example of one of those up in the tour if you come along to that. Or it could be a lab project or a field project or a computer-based project, depending on what your interests are. Because we've got this really broad range of scientists, we've got quite a range of options available for honours dissertations in our degree programmes. Okay, we're at the end, and I'm not at the end. So we do teaching. And I guess the most important thing is that with Earth Sciences degree, we do quite a lot of our teaching outside in the field. It's very effective. We go to all these places, which bizarrely are all in Scotland, even this one. And that's because they're available to us very easily because we're in the same country. But we also go outside of Scotland. We go out with Scotland in some of our field trips. Because if you want to see active processes going on, if you want to look at an active volcanic rift, you have to go to outside of Scotland. You go to Iceland. Or if you want to look at kind of tropical marine processes, you have to go to somewhere like Jamaica, because we don't have much tropical marine in Scotland. Right? If you want to go and just look at the relationship between active tectonics, deformation, and sedimentary basins, Cyprus is quite a good place to go and do that kind of thing. Just mention that some of our degrees have an option, most of our degrees have an option to study abroad. I think all except environmental geoscience kind of make this fairly easy. But actually, Edinburgh is a kind of the city where you kind of get the experience of going abroad because lots of students from all over the world come here to study. So you do get a very international experience as part of our degree program. Yeah, we do lectures, practicals, tutorials, just like every university. I won't spend much time on that. Yeah, and I guess to reiterate that point I made earlier about not being able to get a job here unless you're committed to teaching. So we also have within the school, not within the school, within the university, this Institute for Academic Development. So we have basically a whole department within the university which is there to improve and research how to improve teaching kind of methods. So it's really good to have this kind of thing within the university. Not all universities have institutes like this. It's very helpful for developing new teaching practices. I think if you've been to one of the student life talks and things like that, they might have talked a little bit about the support that we provide our students. So there is a lot of support, both academic, so each student will be assigned a personal tutor who will be able to help with things like choosing courses or kind of talking about how your learning is progressing and things like that. But in addition to a personal tutor, which would be someone like me, we also have a range of different kind of routes which you can get pastoral support through. So whether that be through the residence life thingy, which is when you're in your student accommodation, they can kind of help you out with any problems you might have. You know, these every now and then people do have a bit of a wobble or a visit from the police. So we also have the kind of a student support system set up where we have student support coordinators who are separate from the people who are teaching you to kind of administer and arrange things like extensions for reports, you know, things, special circumstances, dispensations if you're ill. So that separates kind of the academic side of things from the being ill side of things, which is quite good because it basically removes the possibility that you get abused by your personal tutor. Does happen, hopefully very rarely. And it can't happen under this system. Anyway. But yeah, there's also a huge range of other support available other than academic and pastoral. There's kind of computing support. If you're going to buy a laptop before you come to university, don't buy Microsoft Office because you'll get it for free at almost every university you could possibly go to. So we have quite good computing support for all that kind of stuff. And then the last thing I want to mention on this slide is this thing, GeoPals, which is actually, we have a system where it's actually set up by the students. It's got very little to do with the academics at all, where students in the third and fourth year, they help out, they run sessions for the first and second years in study skills, in kind of some of the mapping and the structural geology skills, anything that they think the students lower down in their kind of passage through university would benefit from. And it's, I guess, one of the most important things, hopefully, that you will realise by the end of your degree is that you learn a lot more from each other than you do from the lecturers. So having a really good kind of set of students to work with is a really important part of the study time in Edinburgh. Jobs. People have jobs when they leave. It's not guaranteed. So this is just a list of some of the kind of careers that our students have gone into over the last couple of years. So some of these are quite degree specific. So an environmental consultant or a park ranger or forestry or resource discovery. So that's, you know, oil, gas, minerals, that kind of stuff. But actually quite a lot of our students go on to further research. Actually one student has gone straight into a lectureship from a degree, which is depressing for me. Anyway. Really good for her. But you also have all of these jobs that are available to you because you have a just general geoscience, well, you have a general physical science degree. Nothing kind of, you're not reducing your kind of employment opportunities by taking a geoscience degree. Talking about careers, so the career service, I think they might have a stand somewhere. They're really good in Edinburgh. When I went to university, career services was for like, if you had to visit the career service, you'd lost the game. But the career service here are really very useful. They set up one-to-one meetings to advise on how to write your CV better, how to develop your CV. They can also help with getting work over the summer or internships and things like that. So the career service, very good. Okay, so we're getting towards the end, and I'm only just a little bit over time, so good times. So just to point out the kind of offers that you might like to get. We typically, our minimum offer for Scottish Highers, depending on whether you're in S5 or S6 or how many times you've resat things. Minimum is A, B, 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 A, B, B, B. 3 Bs and 1 A. But more typically, you might get a 4A offer. Okay, now, if you miss that offer on results day, then there is some scope for flexibility. You have to ring up, like, basically the university through clearing. But the degree of flexibility does depend on your contextual background, so whether you're from a deprived area or not. A-levels, same kind of story. We have a minimum. You'll probably get this offer. We can be flexible with that on results day a little bit. Also encourage applications from kind of HNDs, HNCs. We get a couple of those students each year, and they do very well. So yeah, so we do go through clearing. So if you just miss, then ring us up. Okay, so why study Earth Science at Edinburgh? Just to sum up, so Earth Science, I just really can't understand why anyone would not want to study Earth Science, actually. The Earth is really interesting. It's really, I mean, you like living on it, right? Without it, it would be difficult. So studying it is obviously an important thing to do. There are some reasons here. Some of them are more important than others. But I think one of the strongest things is Edinburgh is a really cool city to live in. I mean, even as an old person like me, it's really fun. There's lots of stuff going on for students. I mean, there are 3 other universities in the city. So there's a huge student population. So there's lots of fun stuff going on. And also, Edinburgh is in Scotland, right, which is a fun country to live in and go and hike around and cycle in a kilt or any kind of... Never cycle in a kilt. Okay. Right. So that's the end of the talk. Now we begin the tour. So we've got Lauren and Doug, who are going to come on the tour with us. If you want to stand up and wave your arms around. Some of our current students. And we're going to go on a quick visit to our teaching lab on the top floor of this building. So if anyone is not okay with climbing 5-ish flights of stairs, then make yourself known now and we'll get the lift. But we can't all get the lift because it's a little lift. So anyway, so we're going to go shortly.